Okay, this next problem right here, there's three parts. They're all quickies, right? You just have to write down the general solution of each of these linear differential equations that are homogeneous and have uh, constant coefficients, right? So this is quick. This is just basically find the characteristic equation of each of these and follow the guidelines, right? Whether they're both real and distinct, whether they're both real repeated, or they're both complex. Okay, so the characteristic equation for this one is 2r squared plus 7r minus 4 equals 0. And now you can use either the quadratic formula or factor this. These actually factors. This factor is 2r minus 1 r plus 4 equals 0, which means that r equals a half or r equals negative 4. And because they're both real and distinct, right? Both real and distinct, we know that the general solution is going to be C1 e to the 1 half t. 1 half t is the same as t half, plus C2 e to the negative 4 t. And that is the general solution of that one. Okay? Now, let's do the next one. Next one, the characteristic equation is r squared plus 8r plus 16 equals 0. These factors are r plus 4 squared or r plus 4, right? So in any event, the solution is r equals negative 4. It's repeated multiplicity 2. Right? So it is real, repeated. So that means the general solution is going to be C1 e to the negative 4t plus C2t e to the negative 4t. Right? That's the other case. The other case, you add the t. And then, lastly, the characteristic equation for this one is r squared plus 4r plus 6 equals 0. Well, this is going to be the complex case. This is not going to, you cannot factor this. So we have to use the quadratic formula. So this is going to be r equals negative 4 plus or minus the square root of b squared. B squared is 16 minus 4 times a times c. All that over 2 times a. A is 1, so just 2. And then this is negative 4, simplifying, plus or minus the square root of 16 minus 24. 16 minus 24 is negative 8 over 2. Now let's keep simplifying this. This is negative 4 plus or minus 2 square root of 2i, right? All that over 2, which simplifying, you have to factor out the 2 from above and then cancel. So if you do that, you're going to get negative 2 plus or minus square root of 2i. Right, so we have the solutions are complex. So the general solution, the roots are complex, so the general solution is going to be C1 e to the negative 2t cosine of square root of 2t plus C2 e to the negative 2t sine square root of 2t. Okay, that is the general solution of Okay, that's all. Right, you should know all three cases. Okay, for the next problem, we have to take the function u of t equals -2 cosine pi t minus 3 sine of pi t and write it in amplitude phase form using cosine. So we have to write in the form r cosine omega naught t minus delta. Okay, this problem is rather um, simple as long as you know the formula, right? First of all, the omega naught, we don't really have to do anything for that one because that's just going to be the same as, right, that, but it's in front of the t. Omega naught t, and then you have pi t, so omega naught is just going to be pi. Then we have a formula for the r, that is the square root of a squared plus b squared, which a and b are these coefficients of sine and cosine. So this is just going to be square root of -2 squared plus -3 squared, which give you square root of 4 plus 9, which is square root of 13. So that means r equals square root of 13. So now we have 2. We need only one more thing, and that is the delta. So the delta, we have the formula for that as well, equals, with an asterisk, right, because we have to double check whether the angle is correct. The formula is going to be equal to arctangent of b over a. This is the same as the arctangent of -3 over -2, which is equal to, simplifying the negative signs, arctangent of 3/2. Now, arctangent of 3/2, that is an angle that is between 0 and 2 pi. This is an angle that is between 0 and 2 pi. You can double check that with the graph of the arctangent, uh, right, or with your calculator. The graph of the arctangent, if you remember, looks like that. So if you're plugging in 3/2, which is a positive number, you're going to get something here in this piece that is pi over 2, and that is 0. So you're going to get a number between 0 and pi over 2. Or you can just put it in the calculator. But either way, this number right here is between 0 and 2 pi. And however, the coefficients here are -2 and -3, right? That is a point, cosine, remember, goes with the x-coordinate and sine with the y-coordinate. That is the point -2, -3. The point in -2, -3 is not, I mean, this is like between 0 and pi over 2 is quadrant 1. But this is in quadrant, the point -2, -3 is in what quadrant? That's the third quadrant, right? So this is quadrant 1, this is quadrant 1, but -2, -3 is in quadrant 3. So we need to fix this then. We're going to fix it by adding pi. So that means delta is actually going to be arctangent of 3/2 plus pi. Right? And now we have found everything. We have found the omega naught, the r, and the delta. So now we're going to write u. U is going to be, so let me write it with this. U is going to be r, which is square root of 13, and then cosine, omega naught, which is pi, t minus, and then delta, and delta is all that, so I'm going to put in parentheses, arctangent of 3/2 minus, or plus pi, plus pi. Okay, and that is the answer. Okay, now we're going to solve this problem, which is on using the method of variation of parameters to solve a differential equation. We're first going to find a particular solution, and then we're going to write down the general solution. Okay, so first of all, we need to solve the associated homogeneous equation. So first we're going to solve y double prime plus y equals 0. Okay, that one we know how to do. First, the characteristic equation of that one is r squared plus 1 equals 0, right? And then solving this, you get r equals plus or minus I. And therefore, since the solutions are complex, that means the complementary solution, right, the general solution of this, which is the complementary solution of that, the complementary solution is C1 cosine of t plus C2 sine of t. So that is the complementary solution. Now, the particular solution, according to the method of variation of parameters, is going to be of the form u1 y1. This is my y1, and so it's going to be u1 cosine of t plus u2 y2, and this is my y2 sine of t, right? Where u1 and u2 are functions that we need to figure out what they are, but we have formulas for them. So so we can just use them. So for clarity, I'm just going to write here what we said y1 is. Y1 is cosine of t, and y2 is sine of t. Right, that's what we said. These y1 and y2. So the particular solution is of the form u1 y1 plus u2 y2. All right. For the formula, we're going to need to figure out what is the Wronskian. The Wronskian of y1 and y2 is 1. We did this actually in class. This particular one, the Wronskian of cosine and sine is 1. We did that, so I'm not going to do it again. But you can do it for practice. We got that it's 1. And then the formula tells me that u1 is going to be the integral of minus y2 g of t over the Wronskian of y1, y2 dt. Right? These formulas, you just look them up. You're going to have them on the test anyway. So this is going to be the integral of negative y2, we said is sine of t, so negative sine of t. G of t is this right here. That is g. It is 1 over sine of t. So 1 over sine of t, and this should be kind of bigger. Okay, and all that over 1 dt. So this is the integral of, now over 1 doesn't do anything. The signs cancel. So you really end up with negative 1. So negative 1 dt, and the integral of negative 1 dt is just negative t. And again, we don't put the plus t because we're looking for one function u1 that makes this work, a particular solution, not the general solution. So negative 1 t. All right, so then that's u1, and now we use the formula for figuring out u2, which is the integral of y1 g of t over the Wronskian of of y1 y2 dt, Again, this is 1, so it's not going to do anything. And then y1 is right here. Y1 is cosine, so this is cosine of t times g of t, and this is 1 over sine of t dt. This is the integral of cosine of t over sine of t dt, and this integral is the ln of the absolute value of sine of t plus c. Okay, we're not going to write the plus c. All right, that integral right there, you can do with a u sub. You can let u be the sine, and then du is going to be cosine of t dt. Or you can just use the hint that I put here. I mean, I put that hint over there because, you know, the exam, this is an old exam question, and on the exam you have less time, so I just said, okay, that's basically the antiderivative. This is a cotangent, right? Cosine over sine is a cotangent. The antiderivative of cotangent is the ln of absolute value, but you're going to have more time on the actual test, so I'm probably just not going to put that hint there, but this is a u sub, okay? You find this doing a u substitution. Okay, then now that we have u1 and u2, we have the particular solution. The particular solution is u1, which is negative t, so negative t cosine of t, plus u2, which is this thing, times sine of t. I'm going to put the sine of t first. It's going to look better. Ln absolute value of sine of t. Note one more thing, though, that we don't actually need the absolute values in this problem. Why? That is because they told us that t is between 0 and pi. When t is between 0 and pi, the sign is actually positive, right? Sine is the y-coordinate, so we're like quadrant 1 and quadrant 2. That is positive. So actually, you don't really need these absolute values. So that means the particular solution is just negative t cosine of t plus sine of t ln parentheses sine of t, right? And again, that's because t is between 0 and pi. So between 0 and pi, sine is positive, so you don't need the absolute values. And now that we have the particular solution, the general solution is going to be, the general solution is, right, the complementary solution plus the particular solution. So this is the complementary solution, which is C1 cosine of t plus C2 sine of t. That's the complementary solution, plus the particular solution, plus negative t cosine of t plus sine of t ln of sine of t. So that is the answer. Okay. Okay, and here's the last problem from the practice test. We have to use the method of undetermined coefficients to find a particular solution to the equation y double prime plus 3y prime plus 2y equals 4t, and then we're going to write um, the general solution. Okay, first we're going to solve the associated homogeneous equation. This is our the characteristic equation is r squared plus 3r plus 2 equals 0. This is r plus 2, r plus 1 equals 0. So that means r equals negative 2, r equals negative 1. So that means the complementary solution is c1 e to the negative 2t plus c2 e to the negative t. Okay, that is the complementary solution. Once you have the complementary solution, okay, now let's find a particular solution. For a particular solution, right, the method of undetermined coefficients is the method of educated guess. So we're going to look at the form of that, of the non-homogeneous term, which is 4t, and based on that, we're going to make an educated guess. Now, 4t is a linear polynomial, right? A polynomial of degree 1. So that means that our educated guess should be a polynomial of degree 1, which is at plus b. That should be the particular guess. Now, we have to double check though that there's no overlap, right? That there's no repetition between the particular solution and the complementary solution. If there are repetitions, then we have to multiply by t. But there's no repetition, right? There's no e's here, so there's nothing that is the same. So we don't have to multiply by t. So that should work then. So that's going to be our particular solution, and now we have to figure out what is a and what is b. Okay, since this is going to be a solution, that means when we plug it in the differential equation, we're going to get something that is true. So let's find the derivatives so we can plug them in. The first derivative is a. The second derivative is 0. So plugging in, that means starting with the right-hand side, so I'm going to put on the left. So 4t should be equal to yp double prime plus 3yp prime plus 2yp. Now, yp double prime is 0. Then yp prime is a, so plus 3a plus 2. Yp is at plus b. So we get, simplifying, distributing here and collecting like terms, we get 2at plus 3a plus 2b. And that's supposed to be equal to 4t. Okay, now comparing, right? You have these two should be the same. Those two should be the same. So that means that 4 should be equal to 2, comparing the coefficients to a. 4 should be equal to a. So that means a should be equal to 2. So we found that a equals 2. And now that should be equal to 0 because that's a constant term. So that means that 3a plus 2b should be equal to 0. But a is 2, so that means really 6 plus 2b equals 0. So that means b equals negative 3. B equals negative 3. Alright, and then that means a particular solution is 2t minus 3. So that's a particular solution. And then the general solution. So this is going to be a particular solution. And then the general solution is the complementary solution plus the particular solution. The complementary solution is c1 e to the negative 2t plus c2 e to the negative t. That's the complementary solution, and the particular solution is 2t minus 3. And that is the general solution. That is the general solution. Okay, and that completes